5 minutes after starting her run, a jogger traveled 5/8 of a mile. After 20 minutes of running at a constant speed, she traveled a distance of 2.5 miles. A, write an equation that shows the distance D the jogger traveled T minutes after she starts her run. B, what is the slope of the line? Explain its meaning in this situation. C, how long would it take her to run 10 miles? For part A, we want to write an equation that shows the distance the jogger traveled T minutes after she starts her run. Now I'm going to work this problem in terms of Y's and X's first, and then I'll convert to D's and T's in the end. We're given two bits of information in the problem. We're told that 5 minutes into her run, the jogger has gone 5/8 of a mile. And 20 minutes into her run, she's gone 2.5 or 5/2 of a mile. And I'm going to convert that 2.5 to 5/2 so that it'll make my calculations a little easier. Now, first thing I want to do is I want to calculate the slope. So we have 5/2 minus 5/8 over 20 minus 5. And I need to get a common denominator here, which will be 8. So I'm going to multiply 5 and 2 by 4. So I have 20 over 8 minus 5 over 8, all over 15. That gives me 15/8 in the numerator. And I want to divide by 15, which is the same as multiplying by 1 over 15. And those cancel, the 15s do, leaving me with a slope of 1/8. Now I'm going to take that slope in one of these points and plug it into our equation y minus y1 equals mx minus x1. So we've got y minus, and I'll use 5/2 here, the 20 and 5/2, equals 1/8 x minus 20. And that gives us y minus 5/2 is equal to 1/8 x minus 20 over 8. And I'm going to add 5/2 to both sides. So I have y is equal to 1/8 x minus 20 over 8 plus 5/2, but 5/2 is also 20 over 8. So my equation is y is equal to 1/8 x, which is the same as distance equals 1/8 time, or d equals 1/8 t. Part B, what is the slope of the line? Well, the slope is equal to 1 over 8, and its meaning in this situation is that it represents the jogger's running speed in miles per minute. So with this, its slope is equal to speed in miles per minute. Part C, how long would it take her to run 10 miles? So 10 miles being the distance, and again we're using the equation d equals 1/8 t, we're going to plug in a 10 for d and solve for t. So after we multiply both sides by 8, we have t is equal to 80 minutes, which is the same as 1 hour and 20 minutes, which is the same as 1 1/3 hours.